This is our oscillator setup. The output is connected to pin 3, and now we are following the oscilloscope probe. As what you can see here, the output given by the oscillator is 1 MHz.
This is the frequency divider part. For first of all, we divide it by 2. Next, we divide the frequency divider by 4. For the next situation, the frequency divider is divided by 8. Then the frequency divider is divided by 16. Lastly, the frequency divider is divided by 32.
This video will show to you our log range. Our log range starts from 733 kHz up to 12.9 MHz.
For our frequency synthesizer, first we connect our PLL to our frequency divider, and then from our frequency divider, which is CD4040BD, we connect our frequency synthesizer to a switch, which is DIP10. Okay. And then from there, our pin 9 is connected to the switch, and then for pin 9, we'll multiply by 2. As you as you can see from the wave, it gives us times 2. And for our pin 7, will be multiplied by 4. And you can see 4 megahertz is generated. Lastly, our pin 6, we will multiply by 8.
This is our water tank setup for our application part. Now what is happening will be there are some water inside the tank, and we are constantly monitoring the distance between the ultrasonic sensor and the water level inside the tank. As you can see now, the water level is about 18 cm, and now we're gonna add some water inside the tank slowly. As what you can see, the distance between the ultrasonic sensor and the water level inside the tank will be decreasing slowly. Now we are adding more water, and you can see a level of warning which is been marked with blue color here. And once we reach this level, the ultrasonic sensor will detect it and send the signal to the other side using RF module. Okay, now we have reached the danger level. As you can see, the water level is less or equals to 10 cm. It will start to send signal through this RF module to the other side of the application.
Now we are receiving warning level from the tank side, and it represented as 1 in the video.
This is our control room, and this whole system supposed to start with 2 MHz, but we prefer to show to you step by step. Now first of all, 2 MHz will be switched on. This is the ready setup for this application, where at 2 MHz we will receive a message of character 1 and the buzzer will be on for that. The buzzer will function to alert anyone in the control room, and once a person is alerted, he or she will switch on to 4 MHz to actually know what is happening on the other side of the building, and the LCD will tell in detail what is actually happening. As for this case, unsafe water level, and this is functioning at 4 MHz. And for the action, now we are going to send a character 2 by switching on 8 MHz, and the character 2 is being sent now. As what you can see, it's actually operating at 8 MHz, and we will see at the other side. Now at the tank side, we are receiving the character 2 from the control room, and once we have received the character 2, the valve will be open and allow some water to flow out, and once the level is being reached safe, the valve will close, and that's all for our application.